Hi, welcome back to this channel. In this video, we're going to discuss three objective questions. So the first question is question number 5 in tutorial. So based on the energy level diagram above, which of the following is incorrect? So when you look at this energy level diagram, so you will notice this one is quite similar with what we learned in semester 1, chapter 2. Okay, so yes, then you can see that there is a so-called like y-axis which label with the energy at the left hand side, but this energy level diagram is without the energy level. Okay, we are not showing the energy level n equal to 1, 2, 3 lah. Okay, then next one we have to start with the option A. The dissolution of the solid NaCl is an exothermic process. So again, this show that how important that we need to know the definition for the type of enthalpy. So this solution basically is referred to NaCl solid dissolved in water. So once dissolved in water, will produce Na plus aqueous and also Cl negative aqueous. So when we look at here, we notice that this is the NaCl solid and this is the Na plus aqueous with the Cl negative aqueous. So from here, the energy involved is the delta H3. So we notice that it is absorbed energy because the energy is increasing. Okay, so absorbed energy which is equal to positive. And then is endothermic process. So option A is correct. Next one, we focus on the question B. Question B, basically we see that it's equal to, means that we are going relate with the Hess's law. So when we want to focus on the Hess's law, maybe we need to identify where is the starting point. Yes, the starting point is here, solid NaCl, because we can see there is two arrows come out from this. Then the next one, we're going to determine the destination. So this is the destination. Again, we see two arrows pointed to this place. Okay, so let's label first. This is the starting point, and then this is so-called destination. So when we look at here, we have one step which is delta H3. Okay, we can directly go to the sorry, maybe I try to use another color. When there is a delta H3, one step I can reach the aqueous ion, or another way is we must go through the delta H1 over here, followed by delta H2. So that's why it's equal to delta H1 plus delta H2. But then here we want to get the delta H1 at the left hand side. So means that we are going to move delta H2 to another side. End up we will get delta H1 equal to delta H3 minus delta H2. So option B also correct. So delta H3 is the enthalpy of hydration. So just now we already mentioned that H3 is the solution over here. So that's why option C is wrong. Next one, the last one, delta H1, we notice that here, solid ionic compound and then produce gaseous ion. So if it is the lattice energy, normally is referred to formation. So if formation is from the gaseous ion to form solid ionic compound. But because of this one is the other way round for the delta H1, the NaCl is the reactant. So that means we reverse the equation. So once we reverse the equation, we have to put the negative side in front to show that the equation need to be reversed. So option D also correct. So the answer for this question, which following is incorrect, is the enthalpy of delta H3 is the enthalpy of hydration. So basically, if we want to correct the enthalpy of hydration, so again we need to understand the meaning of hydration is the gaseous ion hydrated in water. So once gaseous ion hydrated in water, you will get the aqueous ion. So in this case here, gaseous ion become aqueous ion, which is delta H2. So if you want to correct this one, the delta H2 is wrong. Delta H2 is enthalpy of hydration. Objective question number 6. We are given two thermochemical equation. So let's label with equation 1 and equation 2 first. Use the data above and then calculate the standard enthalpy change for the reaction. So when we look at this kind of question with a few thermochemical equation and then ask us to look for the standard enthalpy change. So basically we have idea, we are going to apply the Hess law. So when we want to apply the Hess law, then we have to start from the step 1 here. Step 1 already give us the chemical equation. So step 2 we have to look at here. Sodium can be found in the second equation. However, at here have 2 more sodium, here needs 6 more of sodium. So we have the idea that equation 2 going to multiply with 3. So once multiply with 3, so we'll get 6 more of sodium gas and then 3 over 2 more of oxygen gas, and then going to produce since times 3 more of sodium oxide. So the delta H will equal to negative 423 multiplied with 3 as well, which is equal to negative 423 times 3 is equal to negative 1269 kilojoule. So then next we already settle for the sodium. Then next part we can see that we going to look at the aluminium oxide. So aluminium oxide can be found in the first thermochemical equation. However, at the first thermochemical equation, aluminium oxide acts as the product, but in the question, the aluminium oxide is the reactant. So means that we are going to reverse the first equation. So here we have aluminium oxide solid, and then going to produce 2 more of aluminium gas and 3 over 2 more of oxygen gas. So the delta H at this moment, because we reverse the equation, negative 1590 will equal to positive 1590 kilojoule. Okay, so then now we're going to combine these two thermochemical equation. So yes, we have 6 more of sodium, which is needed. Okay, and then we also need 1 more of aluminium oxide, also here. 2 more of aluminium, so this is the 2 more of aluminium. Produce 2 more of aluminium gas. So this one also settle, and then plus 3 more of sodium oxide. So this is the 3 more of sodium oxide. 3 more of sodium oxide solid. Okay, sorry, this one here also missing out the solid. So all the things that we need is already circled. So 3 over 2 more of oxygen at the left hand side and 3 over 2 more of oxygen gas at the right hand side. They can be cancel out each other. Then press the calculator, we will have the answer. Delta H equal to positive 321. So kilojoule per mole. So the correct answer will be donkey for question number 6. Tutorial question number 7. Heat of combustion for 1 mole of carbon, hydrogen, and ethanol C2H5OH is 286.1368 kilojoule. Okay, however, to keep in mind that combustion is the heat release when 1 mole of substance is burned. So if heat release, that means it is exothermic. So going to have negative sign on all these, where in front all these magnitude of the enthalpy. Next, what is the formation of the enthalpy of formation of the ethanol? So definition for the formation of ethanol is 1 mole ethanol formed from its element. Okay, so we already settled in trying to understanding the question. Next, as usual, step number 1, we're going to write the thermochemical equation for each of the information given. So the first equation is combustion of carbon, means burn in excess oxygen. We're going to produce carbon dioxide gas, which the enthalpy is negative 393 multiplied with, negative 393 kilojoule. Next, we're going to write the combustion of hydrogen gas. Combustion of hydrogen gas will produce H2O liquid. So here we need to put 1/2 mole of oxygen gas. Enthalpy is negative 286 kilojoule. Next one is the enthalpy of combustion of ethanol. Formula of ethanol C2H5OH, and then burn in excess oxygen, going to produce carbon dioxide gas and water. So this equation is not balanced yet. We have 2 carbon, so 2 mole of carbon dioxide, 5 plus 1, 6 hydrogen, so 3 mole of water, 3 plus 4, 2 times 2, 4, so 3 plus 4, 7, so 7 minus here 1 is 6, so that's why here will be 3 mole of oxygen, and the enthalpy is negative 1368 kilojoule. Next, we need to write the enthalpy of the formation of ethanol. So 1 mole of ethanol is formed from its element. So the element that can be found in ethanol is carbon, solid, and then hydrogen gas, and then the next one is the oxygen gas, which will produce C2H5OH, where we have no idea what is the value of the enthalpy change. Before we continue, we have to make sure this thermochemical equation is balanced. 2 mole of carbon, 3 mole of hydrogen, and 1/2 mole of oxygen gas. So means that we're going to calculate the value for this enthalpy of formation of ethanol. Okay, so as usual, before we proceed, we have to label the thermochemical equation that we write out recently with the numbering, first, second, and third equation. Then we start from the thermochemical equation that we need to know its enthalpy. The first one is carbon, so we can find the carbon in the first equation. Here is 1 mole, but here is 2 mole. So first equation going to multiply with 2. So 2 mole carbon react with 2 mole of oxygen gas, going to produce 2 mole of carbon dioxide gas, and then the enthalpy will be negative 393 multiplied by 2. So settle for the 2 mole of carbon. This is what we want. So we circle first, also no problem. Next, hydrogen gas. Hydrogen gas is in the second equation. Here is 1 mole, but here is 3 mole. So means that second equation going to multiply with 3. 3 mole of hydrogen gas plus 3 over 2 mole of oxygen gas going to produce 3 mole of H2O liquid. So delta H equal to negative 286 multiplied with 3. So again, 3 mole of hydrogen gas is needed. So we circle first. So next one, we look at oxygen gas. Basically, oxygen gas is in all the first, second, and third equation. So, and then we already used first and second equation. So that's why now we maybe can ignore the oxygen gas first. So we proceed with the ethanol. So we notice that we can find the ethanol in the third equation. But now the coefficient here is 1. Here also consider 1 more. The difference now is C2H5OH in the thermochemical equation that we wish to get the enthalpy change is the product. However, from the thermal equation that we write based on the information given, the C2H5OH is the reactant. Means that we're going to reverse the third chemical equation. Once we reverse, so will be 2 mole of carbon dioxide gas react with 3 mole of H2O liquid, then produce 1 mole of ethanol. Sorry, here is liquid, and then plus 3 mole of oxygen gas. So since the equation is reversed, so the value will become positive 1368. So again, C2H5 is the one that we need. So we circle first. Then next one, we're going to cancel out those that we are not circled. 2 mole of carbon dioxide, 2 mole of carbon dioxide can totally cancel out. And then 3 mole of H2O also can be cancelled out. Okay, next we have 2 mole of oxygen plus 3 over 2 mole of oxygen gas. So here total out is 7 over 2 mole of oxygen gas. But here we only have 3 mole of oxygen gas. So it means that we can cancel out this. But then end up, this one we have 1 over 2 mole of oxygen gas, which is also what we needed over here. So end up, we will have 2 more carbon solid plus 3 more hydrogen gas and 0.5 more of the oxygen gas. Then we will have the 1 more of ethanol. So then we total up all this number, we will get the enthalpy change is negative 276 kilojoule per mole, which the answer is A. So we are going to end this video, which we again discuss 3 questions which apply the Hess law with the algebraic method.